We're here at the Pangolin office about to test LASORB's ability to protect a Blu-ray laser diode. LASORB is a small component about the size of a capacitor, has two wires on it, and what you do is you connect these two little leads from the LASORB directly to the two leads of a laser diode, and that way it's able to protect the laser diode. We were sent a Blu-ray laser diode from a client. This is a 405 nanometer sharp laser diode, like the ones that are used in HD DVD players and the modern Blu-ray players. And so, everybody's heard how static sensitive a Blu-ray laser diode is, and so we wanted to put our little LASORB device to the test and see if it can protect a Blu-ray laser diode. So to aid in that testing, we're going to enlist the help of this instrument here, which is an ESD gun. What this does is it simulates what will happen if a human was to walk across carpet and walk up and touch the laser diode or whatever it is that you're discharging. This instrument has a dial on it which allows me to control the amount of voltage that comes out and kilovolts, and some other controls here that allow me to control whether we get a single discharge or multiple discharges. So we'll go ahead and start off slow here. What we've got is we're going to be putting out negative ESD, and what I've got here is just a little battery pack and a couple of resistors that I'm using to apply power to the Blu-ray laser diode, just to power it in the simplest form possible. So what I've got here is the instrument set for 8 kilovolts negative ESD. And what I'm going to do here, and one more thing about this instrument I want to show you, I'm going to discharge a couple just right here to the clip. And what you hear is each time I pull that trigger, you also hear a little beep. The beep tells us that we've got a discharge. If I hold it too far away and pull it, you hear that I don't have a discharge there. So it's only that when we hear the beep that we have a discharge. So I've got it set for 8 kilovolts right now and negative ESD, and what I'm going to do is hit that anode lead right there with 8 kilovolts negative ESD, and as you can see, it's not even phasing this Blu-ray laser diode. So let's go ahead and crank this sucker up to 16 kV and see what happens now. So we still got negative ESD. I'll pull the trigger. You see the spark is quite a bit brighter now, but still not even phasing that Blu-ray laser diode. And pulling trigger, it's just kind of boring. So what we'll do is we'll set the instruments to give us 20 shots a second here at 16 kV, and let's see what happens now. So as you can see, I'm putting 20 shots a second at 16 kV directly across that laser diode. Of course, it's being protected by LASORB. And what you see is that it's just not even phasing that Blu-ray laser diode. So now let's change the experiment a little bit. What I'll do is I'll switch over the instrument. Instead of producing negative ESD, we're going to produce positive ESD. And positive ESD is the type of ESD, the polarity, that will tend to forward bias the laser diode. Negative ESD is reverse biasing the laser diode. The LASORB has a reverse bias protector in it, and that's one way in which it's able to protect the laser diode. Positive ESD is a lot more difficult to protect the laser diode against, and in fact, I don't know of any other device that will protect a laser diode against positive ESD. So we've set the instrument up here, and we'll start off kind of slow, maybe 6 kV, and we'll go ahead and apply the power again, and this is an even more difficult test because the laser diode is already up, it's already lasing, it's already producing light, and so any additional voltage will ordinarily tend to make it produce even more light. So it's just a much more hazardous test. So we've got 6 kV here, and so there we go, 6 kV directly into the anode, positive ESD. It's not really even phasing the Blu-ray laser diode now. And so I'll crank it up. Maybe we'll take it a little bit slow. We'll go up to 10 kV, see what happens now. See the spark's a little bit brighter, still no problem. And what the heck, let's go for gusto. We'll go for 16 kV here. Still no problem. And now let's give it the ultimate test. 16 kV, 20 shots a second. This is positive ESD, the most difficult to protect a laser diode from, especially while it's lasing. You can see and hear that spark. Positive ESD, no problem whatsoever. Okay, so you know, this is looking pretty promising, but how do we know that this isn't just a trick diode, or that I'm getting lucky, or that everything we've heard about Blu-ray diodes really isn't right at all, and the Blu-ray diodes are really very robust and, you know, resilient and resistive to ESD. So what I'm going to do is I'm going to cut the LASORB package right off of here. I'm going to try to do it in such a way that you know, everything is still connected in the same way, and the only difference is that the LASORB is going to be gone. So let's see here. Alright, so now what we're left with is just the laser diode sitting here all by itself. It's kind of lonely to me. And so what we'll do is we'll set the instrument up, and I tell you what, I've done this experiment before. I know how it ends. Let's just go for about 3 kV, which is about the lowest I can go and still produce a jump. So there we go. We've got our Blu-ray laser diode, and I'll fire one little shot, and it's history. So gosh, it looks like everything we've heard about Blu-ray laser diodes and ESD is true. They really are sensitive. That is, unless they're protected by LASORB. Now, you know, I tend to think of LASORB like an armed guard at the front of a bank. But this isn't any armed guard. This is an armed guard from Texas. There's nothing going to go through that bank. No bank robber's going to get in. And so this is like a highly trained Delta Force ESD protector, LASORB.